So number 2 deals with a quadratic function. F of x equals negative 2x squared plus 4x plus 6. This symmetry is just the vertical line that's going to divide the parabola into two identical halves. The formula for the axis of symmetry was x equals negative b over 2a, right? Where a, b, and c are the coefficients. So a is negative 2, b is 4, and c is 6, right? In your ax squared plus bx plus c form. So the axis of symmetry is just going to be negative b, which is negative 4, over 2 times a, which is negative 2. So it's really x equals negative 4 over negative 4, which is just going to be 1. So the axis of symmetry would be the line x equals 1. And it's important that you remember that since it's a line, right, that's what axis means. Axis means line. So find a line of symmetry, it has to be an equation, right? Because every line has an equation, and the equation of a vertical line is just x equals some number. In this case, the number is 1. All right. So now the nice thing is, once you found the axis of symmetry was also the x value of the vertex, right? Because the vertex is on the axis of symmetry. So whatever the axis of symmetry is, in this case it's 1, right? X equals 1. The vertex is going to be 1 comma something. So how do I find what the something is? I just evaluate the function at 1. So I'm going to do f of 1, and that's going to give me negative 2 times 1 squared plus 4 times 1 plus 6. And this is going to be negative 2 plus 4 plus 6, which is going to be 8. So f of 1 equals 8, meaning the vertex is just the point 1, 8. So that's your vertex. And really, this function notation, f of 1 equals 8, is just another way of writing an ordered pair, right? Where this is the x and this is the y. So just remember that. And then the x-intercepts, well, the x-intercepts, what was the rule always for finding an x-intercept? You set y equal to 0, but really this is in function notation, so really it's solve y is really f of x. So you're solving f of x equals 0. So basically you're replacing the left side with 0. So you solve the equation 0 equals negative 2x squared plus 4x plus 6. And what I would do here is I would solve this by factoring. So I first factor out a negative 2, and then I'm left with x squared minus 2x minus 3. And then this is going to factor into x minus 3, x plus 1. Right? Because what you're doing there, you're looking for numbers that multiply to negative 3 and add to negative 2. They're negative 3 and 1. So then the solutions would be x equals 3 and x equals negative 1. So those are your x-intercepts. But remember, x-intercepts are points. So this is really the point 3, 0, and this is the point negative 1, 0. Okay? So those are your x-intercepts. And then the domain and range, well, the domain of any polynomial function, right, not just quadratic, right? Quadratic is a second degree polynomial. The domain of any polynomial is going to be all real numbers, which you would write as negative infinity, comma infinity in interval notation. And then the range, now you got to remember what this looked like. This has a negative lead coefficient, right? A is negative 2, which means that the parabola looks like this. It opens down, so whatever that vertex is, in this case it's a maximum point, so the range is going to be everything less than or equal to the y value at that vertex. So the range is really going to be y is less than or equal to 8, because 8 was the y value at the vertex. So how do I write that in interval notation? It goes from negative infinity, comma, up to 8 with a bracket. Alright, so the range is negative infinity to 8, because again, this vertex point was, what was it, 1? It was positive 1? 8. Alright, so the range was negative infinity to 8. Because if you remember, domain is left to right, so how far left and right does it go? It goes from negative infinity to infinity, and range was bottom to top. So how far down does it go? Negative infinity. How far up does it go? Up to 8. Okay, and then it says use, the previous parts to sketch the graph. Well, I mean, you can just sketch the graph first, like I did up there. So just do this. Alright, it looks something like this. And I know this point here is 1/8, which means that my axes are probably right here and right here. So there's my x-axis, there's my y-axis, and I know my intercepts were right here, which is 3, 0, and right here, which was negative 1, 0, and that's it. And I mean, if you want also, you could even label the y-intercept. The y-intercept, when it's in this form, when the function is written in this form, the ax squared plus bx plus c form, the value of c is always your y-intercept. So in this case, your y-intercept is actually the point 0, 6. Now it's not, sketched super accurately, but, that's essentially what it looks like. So there's your parabola. And then 3 is just more of this idea of shifting and doing transformations of functions. So what they tell you here is that these two graphs in number 3 are all just the graphs of y equals x squared, and they've been shifted or reflected. So this first one here on the left, this one has been shifted 3 right and 2 up, because instead of being at 0, 0, the vertex is at 3, 2. Alright? So if you remember, the vertex form of these quadratic functions was this: a times x minus h squared plus k, where hk is the vertex. So in this case, the vertex is 3, 2. So the equation for this one would be 1 times x minus 3 squared plus 2, right? And how do I know this is a 1? I didn't, except for the fact that they told me that these two graphs were just shifts and or reflections. So they weren't a vertical stretch. If that was like a 2 or a 3, or a negative 2 or a negative 3 or something, then it would be a vertical stretch. Right? But in this case, it wasn't a vertical stretch, so that's just 1. Now this one has been inverted, right? Reflected in the x-axis and shifted 3 left, right? So again, a times x minus h squared plus k, since it's inverted, what it means is that a is really negative 1 in this case, and then h, since it was moved 3 spaces to the left, h is negative 3, but x minus negative 3 becomes x plus 3 squared, and it wasn't moved up or down, so k is just 0. So I could write plus 0, but I don't even need to. So it's just negative 1 times x plus 3, the quantity squared. Right? So bottom line here is that negative, that was the reflection, and this was the shift 3 left. And over here with this one on the left, this was shift 3 right, and this plus 2, this was shift 2 up. Now this, number 4, average rate of change, this is an important thing that comes up pretty much on all the tests. Now what is the average rate of change? It's really just the slope of the secant line that connects 2 points on the graph. So for example, this is the graph y equals x squared plus 5, so it looks something like this. So the average rate of change, let's say, let's say this is x, and over here is x plus h. The average rate of change is going to be the slope of that red secant line, right? That's what you call the secant line. So the average rate of change is the slope of that secant line, right? And if this is x and this is x plus h, then this value here, this would be f of x, and then this value up here, this would be f of x plus h. You can't really read that, but the idea is, all right, I'll just label this point. This point is x plus h, f of x plus h, and this point is just x, f of x, right? So what is the slope of that line? The slope is just the change in y over the change in x. So the average rate of change, which is the slope of that line, is just f of x plus h minus f of x over x plus h minus x. And again, that's nothing other than y2 minus y1 over x2 minus x1, right? y2 is f of x plus h, right? This is your y2. This is your x2. This is your y1, and that's your x1. It's just y2 minus y1 over x2 minus x1. That's all it is. So what is f of x plus h? It's just this function, only wherever I see an x, I now replace it with x plus h. So that's f of x plus h, and f of x is going to be x squared plus 5. Right? Technically, I probably should put that in brackets there, so I can show you that this, the bracket is f of x plus h, the parenthesis is f of x, and I'm dividing this by x plus h minus x, where the x's cancel, and I just have h. So what is this? I have to FOIL that, so it becomes that, and then I distribute a negative sign and get that all over h, and this is going to simplify a little bit because x squared and negative x squared cancel, 5 and negative 5 cancel, so now I'm just going to be left with 2hx plus h squared over h. I can divide out, I can factor out an h in the numerator, and now I can cancel the h's that are in the numerator and denominator, and I would just end up with 2x plus h. So that is my average rate of change.